Assalamualaikum and very good morning, distinguished guests, especially Azri. Thank you for having us here. My name is a bit mouthful to pronounce, so just call me Shah. I'm from Plus Berhad, and I'm pretty sure all of you have enjoyed, some of you maybe, or majority of you, have enjoyed the free toll during the last Chinese New Year. And I think everyone is actually wishing for the free toll for the next Hari Raya, right? But that's not a Plus say, so just see what they will say at the end of perhaps Ramadan month, yeah? All right. It's quite a humbling experience to be here to share with all of you our Plus experience in the Plus geospatial transformation. All right. All of you know what Plus and who Plus is. We are the largest expressways operator in Malaysia. Yes, proud to say that we are the backbone of Malaysia Highway. 846 kilometers of the backbone from north to south. At the same time, we are handling about 1.7 million daily traffic. It could go further up, which we lost about 2.3 million revenue, 2.3 million traffic revenue for the free toll during that Chinese New Year. and we are covering about 1,130 kilometers. On the north, we have Penang Bridge connecting the mainland to the island, as well as Butterworth Kulim Expressway. At Central, probably all of you are traversing or commuting to our Plus Highway from everywhere to Damansara today, perhaps. We have also Elite Highway connecting Putrajaya to KLIA, as well as KLIA, as well as we also have the Port Dickson stretch. Down south, we have two highways connecting Malaysia to Singapore. So you will be passing through Bangunan Sultan Iskandar. On east side, we have also maintaining and managing at this point of time our LPT2. That's from Jabo to Kuala Terengganu. Somehow that will shorten the travel period of just about 1 hour between Jabo to KT if you drive really fast. Right? All right. Down there, we are just sharing with you all the assets that we have along the expressway. And we are proud to say that everything is covered by the spatial data, right? So where Plus is now, when we talk about highway, we talk about smart highway. All right, based on the Hindawi Journal of Advanced Transportation, there are 5 levels of readiness in meeting smart highway aspiration, as well as the operations management classification. Let's not go to R5 yet, the readiness level of 5 yet, because the full smart highway will just be materialized if we integrate the smart infrastructure or the highways with smart vehicles passing through it. All right, but what we have done, what we have achieved so far, alhamdulillah, we have set the motion, we have segmentized all the initiatives implemented or to be implemented later in meeting the readiness level. So currently, you can see Plus Geospatial has already been implemented, and that initiative has already been mapped to a partial smart highway. All right? You would also see that there are items or initiatives in the green box that are the other initiatives currently in POC or pilots that maps to conditional smart highway before we can move on to readiness level of 5. All right? Some of these initiatives in R4 is also related to geospatial per se. So you will be seeing something that perhaps attracts your attention is the suicide prevention system. This is quite rampant on our two-bed, sorry, but it's on Penang Bridge especially. So we are putting together the brain, the AI, and machine learning as well as georef, the areas, so that we will have that. We are also later be integrating the way in motion, oversized vehicle detection, so that we will be able to advise our users when we notice that there are oversized vehicles not to pass through the Menora Tunnel. All right? Moving on, how the plus geospatial transformation journey starts. Okay. Our spatial data covering from the moment you enter our highway until you exit the highways. We have 72 layers currently, complied to MS 1759. It's not an easy job, yes, but we did that. And we covers all assets. So when we talk about covering of all assets, we have the data, spatial data that for all our alignment. When we talk about our alignment, the highways, we always refer it as our pavement, our highways. So 1 kilometer corridor of the highway alignment capturing all our assets. So you will be seeing about 10,000 slopes mapped to our highways. Talking about MBSA, we're talking about CCTV, we have just about 3,000 CCTVs. But we do have mapped almost 40,000 street lightings by point, 6,000 culverts. So everything is there from civil and structure assets, mechanical and electrical, as well as the road furnitures. So we map our guardrails, we map everything basically. Whatever you see on the highways, we mapped. Additionally, we also have about 5 kilometer radius coverage for selected locations. We capture information that's supporting to our data. For example, we capture a river. We do capture forests. We do capture transmission line. Just to make sure that whatever that's within or very near our neighbors, so that whatever our activities will not have that adverse impact to both sides. Yeah. On the transformation journey, we actually have utilized ArcIMS way back in 1998 when we embarked or initiated our development of highway maintenance management system. So that was pretty long way before 1998. We used GIS as one of the components. Why we developed asset management system? Because at that point of time, 1998, there was no off-the-shelf product that highway concession like us can use to monitor all our assets. So we use ArcIMS there, but in 2012, we developed Plus Geospatial. Then further enhancement in 2017, utilizing Esri products, basically, ArcView, ArcIMS, ArcGIS for server, ArcGIS API for JavaScript, just to improve the GIS representation and definitely ameliorates geospatial users' experience in profiling, panoramic view, and measurement capabilities. In parallel, you would also see we have transformed the data acquisition methodology when we initiated with digitizing the expert drawing way back in 1998. And then we utilized the 360-degree mapping and LiDAR in 2011. But I'm very sorry, we also embarked on UAV in 2018 with aerial photogrammetry triangulation because of the cost to undertake LiDAR and LiDAR through helicopter and plane, right? So we embark on UAV. I'm proud to say currently we already have 4 units of drone within us so that we can do not only data acquisition but also do aerial surveillance as well as defects detection. And recent one, you will be seeing us, some of you, if you pass through some of the highways, we have started to utilize terrestrial laser scanning, TLS, to scan our existing building so that we will be able to, no, we have actually even established beam onto it, all right? We have already beamed our buildings because, but we go through the reverse engineering process. Right. In 2018, to align with PLUS digital transformation, all relevant spatial data are moved to cloud. A step taken, I would say, for more effective control and performance of the application and the data. So you can see here in the architecture that we actually, along the line, in 2020, we embark on re-engineering of this PLUS geospatial, where we actually change the engine, all right? And we merge, because it's already on cloud, so what we did was to merge SD components with the cloud solutions, and you would be able to see at the site where we actually now interface. So when we interface with other applications outside the asset management system as well. Based on the scope of works to fulfill for the demand for integrated and dynamic mapping system, what we use, the ArcGIS component we use has already been highlighted there. Some of it you will be able to see ArcGIS Enterprise Dashboard and ArcGIS Pro, definitely. While PLUS Geospatial is heavily used, when you see here, we just map maintenance and operations team. But it's also being used by our commercial team with regards to monitoring third-party access of the highway, as well as it is also mapped to our land gazette process application. All right? What we have built up out of this re-engineering process. So what we actually implemented is the linear referencing system. That enhances the PLUS geospatial capabilities to locate everything based on highway convention. Because PLUS operations team, they are very familiar with kilometer marker. And I believe if you got breakdown on the highway, you will also, when you call our traffic monitoring center, they will ask you, sir, madam, which kilometer are you in? Because for highways, we use kilometer marker, so we actually utilize linear referencing system to transpose the coordinates, the conventional coordinates, XY coordinates, to kilometer marker. So we done that. And this application of LRS further extended as a converter for our pavement assessment data. Because pavement assessment data, when we conducted pavement inspection, it's not by kilometer, but it's a smaller parcel by 100 meter squares, 100 points. So it's very detailed, and for that matter, we would be able to give a better visualization to pavement condition, and you would be seeing in the right-hand side the pavement condition assessment data slider. So we have the data for pavement condition way back in 2012. So you will be able to see at this particular stretch, when 2012, how's the pavement condition, whether it's poor or good. If it's poor, you would want to anticipate or expect it, because there will be some repair works done to that pavement, and by next year, it shall go to good. So we have that. And one good point about LRS is actually it gives us the ability to have the self-import data. So users within the same application can share their data more efficiently, and it will be reflected there. And this, together with the images, it will be geotagged. So the pavement inspection team will be able to cross-check the pavement condition with the images, right? Well, again, as I said, besides the historical slider, not only for the pavement condition assessment, but also for the black spot location, accident-prone areas, it gives also, we also have coverage of about more than 70% of our highways that we have the 360-degree aerial panoramic view. That gives, I would say, off-site better visualization of what's there. And if you go in a little bit more detail into the 360 aerial panoramic view, we can actually even go down to the some of the culverts, right? Next, the other features that we develop is actually the when we publish the data through ArcGIS Pro to ArcGIS Server, we actually establish the routing module in PLAS Geospatial. This is to support our PLAS Traffic Monitoring Center, Traffic Management Center, TMC, in providing the traffic status and alternative routes to highway users, not only within the highway alignment, but has the coverage for other adjacent local routes. The moment I click, you will see that besides the alternative routes outside, we also incorporate our relevant asset information. For example, we interface with our asset of emergency median opening. So we actually have developed the additional features for U-turn, as well as activating contraflow that's unique to PLAS operation. So if you got stuck in our highway, if you just go through the PLAS Geospatial, I mean like the normal maps, they will just route you out of the exit. But for our traffic monitoring center, they will be able to advise the team at site where to activate the contraflow or the U-turn point. And this also gives our PLAS operations team and effective measures for incident management, definitely traffic dispersion, and also improve the disaster recovery response time, which supports for definitely safer and smoother journey to all of you. Next is a combination of data. This is what you see the simulation. A combination of data and information, 360 aerial panoramic view, orthophoto images, asset distribution patterns, maintenance and operation team able to now identify a possible hazard, while definitely simultaneously improving the safety for PLAS and highway assets. What you see here are actually the simulation tools that build up, that provide us the early information to prevent inevitable consequences. For example, pollution of water resources resulted from the accident that resulted the oil spillage or chemical spillage, you see, as well as the impact on mud floods flow from the high gradient towards our highway. So currently our analytics is purely based on water flow stream analytics. But again, all of you are aware, accident may not just cause, not water tank accident, but usually it's oil tankers, so that consists of chemicals and other densities, liquids, yeah. So what we are looking forward is actually, we want to include this liquid density parameter into this rule, so that will give us better simulation and output results to the team. Because water density will flow differently and as chemical, as oil and things like that, right? What's next? What's the challenges that we face? Definitely, the challenges in undertaking the PLAS geospatial transformation journey is to keep up with the technology advancement and capabilities. Abandonment of capabilities, and we really need to really choose and pick and try and implement. But definitely these required high technical skill dependencies. Another one is consolidating of our data. We have about 15 terabytes of data currently. All the layers, all the images, the 360 aerial panoramic views, everything. we need to consolidate it in geodatabase ArcSDA. As finally is, of course, to meet the stakeholders' expectation. The moment we show one features, they start to ask us, can we have next additional advanced features? So that is good, but it's also a challenge to the team to keep up with that expectations. Nevertheless, what we have achieved, the opportunities are actually, we have tighten control where we minimize data risk and cybersecurity, because we actually have that covers under cloud, at the same time with all the components in Azure. And then we have increased 25% response times for that application. We allow data sharing, we allow interface to other applications through SD APIs, not only APIs, but also SD APIs. Immediately, we are also sharing. We are now able to share with our regulators, Malaysia Highway Authority, through two medium, whether it's APIs and SD APIs, or even through Azure services. The next one that we are seeing, we have also managed to reduce the manual processes by 50%. Of that manual processes, some of it has gone through the digitalization, as well as whatever features that you have seen just now. We have also allowed everybody to be access to our BIM model into Plus Geospatial. And of course, ultimately, we comply to the governance and standard requirement, MS 1759, as well as MS 1759 is not just to comply to that standard, but also that is one of the terms in our concession obligations. Finally, what's next for Plus Geospatial? Well, we have the long-term, we have established the mid-term, short-term plan, as well as the long-term plan. You have seen here, some of it is already being initiated and ongoing. We are now working towards having Plus Geospatial as a single pane of glass for our traffic monitoring center, where this is aligned to traffic monitoring center modernization initiatives. We will map for currently the incident report initially, and ultimately we will also connect it to our Plus Ronda, doing patrolling on the site. We will also ultimately connect it to other applications, the CCTVs and whatnot. We have already got that on asset management, meaning that you can see the CCTVs, but we will later connect it to the AI brain behind the CCTVs module, right? The next one, we have initiated scan to BIM. What you see on this particular slide, the OBR Sungai Buloh is already BIM, and you would be able to know that you would be able to see the 3D model of that OBR Sungai Buloh. Proud to say that our LOD level for BIM architectural is already 500, but definitely because we are doing reverse engineering, we actually model the constructed building. So for MEP, mechanical, electrical, plumbing, the level of details can just go up to 300. For structural, perhaps 300 or 0, because whatever has been sealed and plaster will not be there. But the detailing, we have already there. And what's best is users don't have to go to BIM application, but they will just go to Plus Geospatial application to view and do all the measurements and get all the detailings of BIM items in there. Right. Next, we have also piloted that we want to go for GeoBIM. We have initiated, in fact, at this point of time, we have completed the data acquisition of GeoBIM projects. We piloted to our Sultan Azlan Shah Bridge, crossing Sungai Perak. It's not long, it's just about 360 meters. And we have started to build up the BIM family to that. So hopefully, by end of Q2 or early Q3, we will be able to see geobeam implemented for Sungai Perak Bridge. And later, it will be expanded across the highway. With this, you will be able to see we work on this with Esri and Autodesk. We also established the common data environment. Perhaps if you want to know more about this, maybe we can share our experience later. What's next? After geobeam of this Sungai Perak Bridge, we will extend it to the rest of 1,000 kilometers highway. You will see all the highways now modeled 3D. Next is to interlace it with other technologies, where we actually prepared for highway information modeling or digital twin. Perhaps we would be able to go 2025 onwards for the level 3, maturity level of which we connected to our sensors, IoTs, robotics. Who knows? But that's where we are heading. What we see the future of geospatial, embracing I 4.0 components, very promising. It's not within PLAS environment itself, but I would say that it has potential to generate new business solutions, opportunities, transform even the landscape of overall services and transportation industries. With that, thank you very much.